Hello and welcome to another episode of the glorious and gorgeous Fully Charged Show podcast. I just can't help getting quite excited about the incredible innovations, the incredible new companies that are appearing all around the world that are doing amazing new engineering, completely throwing out the old manufacturing models, coming up with different ways of making things, different ways of using things, different components in different configurations that would have been impossible, not just difficult, impossible using combustion engine technology. It's just what electrification of our world, results in is amazing innovation. And this company that we're talking to this week and the man behind it are a perfect example of that. So this episode is about a company called REE, R-E-E. They're an Israeli company, and they have developed an incredible next generation skateboard platform for transportation. Let's just leave it as broad as that. It's not for anyone. They're not making cars or vans or buses or trucks. They don't make what you see. They make what makes it go along underneath. So what you see as the bodywork and the design of that and how it gets used is completely liberated by the design they do. And this is, certainly one of the episodes. We're really thrilled to have done this podcast, but it's something that we really want to make an actual video episode of next year, because you need to see it to really fully get it. But what is really good is their website is worth a visit. I'll put the links to that in the show notes for this episode, but because that does sort of describe what they're doing. I'll let Daniel Barel is the co-founder and CEO of REE, who I speak to in this episode, and he explains it very well there. But a bit of visual reference is quite useful if you have a quick look at the various designs that they're coming up with. Just really it is, I think, revolutionary stuff, and just really clever stuff. The corner there, the REE corner, as they call it. It's basically the wheel and everything that makes the wheel turn in each corner of these various skateboards, from very small to absolutely enormous. Is a fascinating new idea. It's just brilliant. It's just extraordinary. So that's what this week's episode is all about. And I just want to remind you, in case you haven't done it, to subscribe to Fully Charged and to tell your auntie and your third cousin on your father's side and that weird bloke down the road that you occasionally see. Tell them about Fully Charged and the Fully Charged Show podcast, because they might be interested. Just spread the word. It does make a difference. The show is growing. The podcast is growing really fast. I wish that 10 years ago, the original Fully Charged show on YouTube grew this fast, because it took a bit longer. But that's doing very well, and there's lots of amazing episodes in case you haven't seen it. Occasionally, I meet people who found the Fully Charged show audio podcast, this show, and don't know that we do the video show, which we've been doing for 10 years. So just in case you don't know, on youtube.com/Fully Charged show, you'll find over 500 episodes. And by this time next year, there'll be an episode about this company, REE, who we're talking to today, because they are amazing. Please welcome to the Fully Charged Show podcast, Daniel Barel from REE. My Energy is putting the I back into British innovation. My Energy is putting the I back into inventing the future. My Energy is putting the I back into inspiring a nation. Recharging the world with green, smart energy. Charge your EV with your PV and more. Visit myenergy.com and help to spark the green revolution. My Energy, driving the charge to a greener future. Daniel, thank you for a start, for taking time to talk to us. What I think you're doing, and I'm going to say this first, and I want you to correct me because I'm bound to be wrong, but I think what you're doing is, it's genius. So it's a bit of flattery to start with. But I've got a lot of questions of it, but the notion of a company that focuses on building the drivetrain and not the vehicle strikes me as an extremely sensible way forward, because it allows a lot of other people to enter the market, if you like, for lots of different reasons. And they don't have to go, oh my God, we've got to build a suspension and steering and control system and batteries and all that. We'll build this amazing top bit and we'll bolt it onto this. And it just strikes me as brilliant. So the thing is, I want to know where that idea came from. And then, but the big question is, in-wheel motors. I can remember hearing a lot about 5-10 years ago, which struck me as genius idea, because it just means everything is in those four corners of the vehicle. But then I haven't really seen a lot of evidence of that in commercially produced vehicles. So I'm assuming you've moved in-wheel motors a generation on further than the very early ones that I sort of heard talking about.
Yeah, right. So first of all, thank you for having me. This is exciting to having a chat with you. I'm a longtime fan, so
thank you.
So we decided to be a strictly horizontal player as opposed to many vertical players in the market, which the industry calls OEMs, right? For a very unique reason. We started this a few years ago, over 8 years now, I think, when we wanted to be a white canvas for everybody to be able to build their dreams on.
Right.
But the problem was that we're not mind readers. I have no idea what you would want to build on.
Yeah.
So we struggled as to what would be a good strategy to give somebody the flexibility to build whatever they want, but on the other hand, to provide an MVP, a minimum viable product, and not a component, something that you can build around.
Yeah.
And that, up until now, did not exist in automotive. However, it does exist in other industries. For example, computers.
Yeah.
If you're a computer manufacturer and you're Dell, Lenovo, or Intel, you don't start building your laptop, for that example, before you stop by, I don't know, Intel and choose the chip.
Yeah.
Right? And you build everything around it, because everything derived from that chip. If you're a commercial aircraft manufacturer, you'd start with the engine. You can't design the wing without knowing the engine. You can't design the body without knowing the wing. So you have to start at the engine. And we thought to ourselves, what would be a minimal viable product in automotive? And we said, okay, what are the first few questions one would ask themselves, right, if they want to build a new vehicle? That would be, what would be the weight, the size, the speed, the load, etc., the usage, the range. Well, those are the typical places where you start drawing around, right? Because everything comes and goes derived from those. So we said we have to have a MVP, a minimum viable product, that would answer all of those. But would be able to stand by itself and be as minimalist as possible. And this is where we came out with these corners. We said, okay, we have got to do the drivetrain, the powertrain, the steering, the braking, the suspension, and the control of all of that.
Right.
Okay, that was easy. We said that's fine. But again, how do you make that it's modular? How can you play with that? So we said you have to take them off the chassis, because every time you change the chassis, right? If you want an OEM to change the chassis of a current vehicle by, I don't know, 6 inches, it's about what, 10 years and $500 million.
Huge amount of money and re-rigging everything.
Makes sense, right? So we said you have to take them off the chassis. Now, we don't come originally from automotive, so we said, okay, that easy. So we'll do the drivetrain, powertrain, suspension, steering, brake, and control, and we'll do them off chassis. Right. Which, if we were to come from automotive, we would not have even considered thinking of that idea, right?
Yeah.
And this is what we've came up with those corner modules. Now, there's been so many challenges to make that happen, because you can't just shrink everything and put it in the corner. Yeah. You can't do the same suspension, but just shrink it there. You can't, for example, use traditional hub motors, because not only that they're unsprung mass and they're very prone to get hit by road conditions and rocks, etc. There's actually a bigger problem that we personally see in hub motors, which is high voltage cables.
Right.
Think about it, there's an accident now and the wheel is detached. You've got exposed high voltage.
Yeah.
And now, God forbid, I don't know, you're in the UK, where I know it's very rarely when it rains, but let's say rain, right? And
Sorry, it took me a moment to get that joke. Yes, I've seen rain here. It does happen. Yeah, no, absolutely.
We had rumors of that. Right?
Yeah.
And
but then, can you explain then? So that, because that's what I have seen in wheel, I would call it in wheel, but hub motors. You're right, and which are common on electric bicycles. That's the general way of, well, not always, but it's very common. But in a car and on scooters, but in a car, then in that design, the actual motor is housed within the wheel, and that's what turns the wheel. But what you're talking about is slightly different to that then.
Correct. We call it close to wheel. So what we're doing is it's still within the corner. It's very, very close to the wheel,
right,
but it's actually on the chassis side.
Right.
So it's fully protected and it's fully encapsulated. But then you've got a problem. Why? Because traditionally, how do you transfer torque from a stationary motor to a moving up and down wheel? You use a half shaft.
Yeah.
But if they're so very close, there's no room for half shafts.
Right. And there's no room for the flexibility. Yeah. Exactly.
So we said, okay, no problem. And we redesigned and reinvented a unique drivetrain that allows us to transfer those torques from that. And it's very, very efficient. And that's what we've done with all of those components. So we are a company where we are in-house developing all the mechanics, mechatronics, hardware and software from scratch.
Wow.
And we actually, that's some of the things we're very proud of. Now, going back to your first question, that allows us to be a very horizontal player in a sense that, as opposed to being a vertical player, an OEM, right? So let's talk about a few exciting OEMs. Sorry about that.
I just want the listeners to know that wasn't my phone. Now you've made me very nervous. I'm just making sure I'm turning mine off. But that's fine. Don't worry.
Let's say we're taking a few OEMs. So you've got traditional OEMs, but for traditional OEMs to build a vehicle, that's what they've been doing for the past century, right? So let's look at I don't know. Let's look at REE. Let's look at Arrival, right? Exciting company.
Yeah.
But Arrival has to do everything, right? They have to do the powertrain, the suspension, the everything, but they also have to do the cabin and the infotainment and the safety and the airbags and everything. And therefore they can only concentrate on so much in the market.
Yeah.
So they choose a segment, and the bigger OEM you have more segments under your belt, but it's still you have to do it all. We said that doesn't make any sense in the future because there are so many players coming in and they want so many different things. So you can't concentrate on everything vertically. So we're looking at completely horizontally. We say, we'll give you those corners, those intel inside. And those are the minimum viable product around which you can build anything you want. You can take any vehicle you want, any size. By the way, any power, we're agnostic to power supply. You can do batteries or you can do fuel cells.
Right.
You can do road, you can do off-road, you can do heavy or fast, any dimension, anything you would want on top of those corners.
Right. That is, I mean, because I think that's the beauty of it, is the freedom that gives, you know, and I've talked to many engineers about this, and particularly in the automotive sector, is the sudden kind of liberation that an electric drivetrain has given them in terms of how they design things. And what I think what's interesting is it's taking a while to come through in private vehicles, in, you know, passenger cars. They're still built so much along the lines of traditional, you know, in terms of the design. They look very like a traditional combustion engine vehicle. They've still got a big bonnet that you can put an engine in. You don't need to. That whole thing. And I can understand there's safety issues within that, but what you're
actually they're not.
Well, I'm beginning to question it. Yeah.
Why is Tesla so safe in head-on collision? Not for many reasons, but the main one is there is no engine.
Yes.
So there are less parts coming into
The passenger. Yeah.
right? And actually you can absorb energy, what they call crash absorbing zone,
Yeah.
much easier. But traditionally, for more than a century now, we've been placing all of those components between the wheels.
Yeah.
And we keep on doing that.
Yes.
So you don't really have, if you think about it today, you don't really have a skateboard chassis. Because if you look at all the skateboard chassis, there are only skateboards in the middle of it.
Right.
Because between those wheels, they're still packed with everything.
Yeah.
So it's more of a
yeah, I mean, the back of a Tesla skateboard is not a skateboard. It's a drivetrain that's quite big and chunky and takes up a lot of space. Yeah. It's
also the front, right?
Yeah, and the front, yeah.
Look at our design, because it's all in those corners.
Yeah.
You can literally walk from one end to the other. It's completely flat.
Yeah.
Now, you can utilize all of this space as you see fit. Now, because that also allows for a very, very low center of gravity, right? It allows you to pack higher while maintaining stability. So we are actually also reducing that footprint, because you don't need that bonnet in the front or the trunk.
Yeah.
So you can utilize all that space.
Yeah. I mean, because that's, you could have then what would, to our eyes now, look like quite an ungainly van, for instance, delivery vehicle, because it could be much higher than we would build at the moment. You could put I don't know what, but if you needed something that was higher, it's not going to be unstable, because all the weight. I mean, you cannot get the weight in four wheels of a vehicle lower than you have. There's no way, unless it's actually resting on the floor. That's the next step.
Correct.
But then, so what I want to know then is, because I don't know how long you've obviously been working on this for some time, but I'm presuming there's got to be some interest then from other companies. Because I mean, I must admit, even if I was an OEM and I'm thinking we've got to develop electric vehicles, but we have this huge factory that makes engines, it makes combustion. How are we going to transition to this? And then I see what you're making and go, if I was the CEO, I'd be asking the head of engineering, can we have some of the stuff they're doing? Because that really makes it a lot easier for us. But are you getting good feedback?
We're getting tremendous feedback. And again, going back to the fact that we're horizontal, we don't compete currently with anybody.
No, there's no one else doing it. No.
If you think about it, let's I don't know, look at another really nice company, quite interesting, Rivian.
Yeah.
Right. So they are connected to Ford.
Yeah.
Right. So it would be quite a surprise if we would see them collaborating with GM or FCA.
Right. Yes.
There's a bit of competition there, right? We're not competing.
Yeah.
I mean, if you look at traditional OEMs today, they're moving away from the mechanics and drivetrain, etc. They're moving towards electrification, batteries. They're looking at autonomy. They're looking at connectivity, and we're actually filling blanks there. Right. But so we work with quite a few OEMs. One of which is Toyota, is Hino, which we announced last year, and now recently Mahindra. But we're also working with a few other players that are not OEMs, mobility players, logistics, deliveries, robotic companies, e-commerce companies that are interested in designing their own fleet, right? And it's a global thing. Let's think of a hypothetical example, completely hypothetical, right? If I were Amazon, I would say, okay, we're global. We are doing the whole supply chain, right? They've got planes and all the way to the delivery guys. So how do I drive these products that people buying online as fast, as efficient as possible? And you want to do it as fast as possible, because as I'm sure you know, the longer the delivery takes, the more chances exponentially for somebody to cancel. But if I can give it to you, for example, within the hour, you won't cancel, right? No. Basically, right? That's it. And sometimes the spoke and hub system of traditional logistic companies is not quick enough. It's 3-4 days, right? So how do you do that? You build a global fleet. This is what they're doing, right? Yeah. Part of the Rivian invest in that. But however, their dream, I would imagine, would be something like a global standard fleet, one vehicle across the
Right.
world.
Right.
Great. But you can't really, I would imagine, take a Rivian and drive it in London, Paris, or Mumbai or Tokyo. It's a class 3 vehicle. It's just too big. It can't maneuver. It will get stuck literally in London in those small streets. It can't pass, right? So what do? You start buying different vehicles. A few Mercedeses, a few VWs, etc., etc. And then they're homologated and fitting the market in which they operate. But then you've got a variety of vehicles that have nothing almost in common.
Yeah.
The maintenance costs are huge, and the commonality is zero. You want to have same ADAS, you can't. You want to have same control. You want to have same spare parts, you don't. Right? Yeah. It's a nightmare. How do you manage that globally? Yeah. You don't.
Yeah.
But in the new era, where this is what they want to do, we bring the perfect solution, right? One vehicle around that corners, that MVP. It's the same corner around the world. So yeah, we can make it a little bit narrower, wider, longer, shorter, higher.
Right.
We can give it 4-wheel drive or 2-wheel drive, but it's the same vehicle.
Right.
Now let's put something on a cherry on top of this and say, maintenance-wise, you have to think about total cost of ownership, right? This is huge here, because it doesn't matter how much does it cost, but it matters how much it is to run it, right?
Yeah.
So let's imagine that, again, you're a fleet manager, UPS, whatever, a FedEx, and Amazon, and you've got a problem with a truck. So you have to bring it into the shop for a technician, a specific technician that knows how to deal with that vehicle and not the other. So you wait until that guy comes, and then he or she looks at it and understand, I don't know, there's a problem, I don't know, in the gearbox or whatever, right? So they order the spare parts, because you can't have spare parts of everything. And in that time, it stays on the lift, and every day it's about $1,000 per day for that. Yeah. And then it gets fixed after roughly 3 days, and off it goes. And what we do is we allow you to replace a corner with a new corner in less than an hour.
Right. And that's technically possible. Mechanically, you can take one off and put a new one on in an hour.
If you were here, we would go and do it together.
Right, right.
You do that with all calibration and everything within less than an hour.
Wow.
There is no spare part. There is one part for one part.
Right.
In and out. So you don't have to have special technicians for that. There's only one kind. You don't have to have spare parts. There's only one kind. It takes you less than an hour to do that. Yeah. And the cost of ownership drops down dramatically.
Because I mean, I think this is where you have the advantage in that sense, is already the cost of ownership of an electric car, private vehicle, is, everyone knows who drives them, is lower, but it's a really hard sell. So what people see is how much it costs when you go in the showroom or when you order it online or whatever. But what the advantage you have, particularly with fleets and with delivery, is I'm sure that's an important aspect, the initial purchase cost, but they're going to look at that 10-year lifespan. How much does it cost to run? How often do we have to service it? All those things. And they're very used to that. You know, you buy 50 Mercedes diesel vans. Part of that deal is, well, this one's going to break down, the gearbox is going to go, the clutch is going to wear out. We've got to have that covered, that cost. And if once people realize, and I think we know of people in the UK with electric delivery companies, and they're not fixing their vehicles. They're not going wrong. You know, they get punctures, they get flat tires. That's kind of it. Body damage, And
let's take it to the next step then. We would be able to allow our customers, let's say you have a fleet of 50 or 100 vehicles. And if you subscribe to our maintenance subscription, during the life of that vehicle, we'll keep on sending you over-the-air updates.
Right.
So you will get new capabilities, similar to a Tesla, right? New capabilities and new functionalities as time goes by.
Right.
Now, if you want to take it even to the next level, which nobody else can do, let's say in 5 years' time, again, part of the agreement between you and I, you'll come by at our shop and we'll replace your corners. Right. And we'll give you new corners, upgraded one.
Right.
So midlife, we're giving you a push, right?
Yeah.
A bump towards the next half-life where you got basically a new vehicle because it's all in the corners.
Yeah.
new capabilities, everything. You don't necessarily have to change the body, the top half.
Yeah.
And we saved you tons of money.
Right. Because that was one of the things I noticed on your site was the idea of preventative maintenance AI. You know, that kind of knowledge of the vehicle. So if you have data coming in from the vehicle, and you go, I can tell that corner's been damaged, even if the driver can't or the company can't tell. There's something, and that's going to,
or it's gonna be damaged.
It's going to be damaged. Yeah.
Come in because something is going to happen within the next 2 weeks.
Yeah.
And even more, actually. We can actually even tell you as a fleet manager, the way your drivers drive that truck in that particular segment is what causing it.
Right.
Would you like us to fix it then?
Yeah. That is amazing. I mean, because what I love about it is it leaves the notion of combustion engines just like in history, you know, because the disadvantages are, the one advantage, you can stop at a gas station and fill it in 10 minutes. That's the advantage. So, okay, what other advantage? None. No, there must be other ones. No, there's not. Can I drive into a city? No. Does it always go wrong? Yes. Is it expensive to run? Yes. You know, the list of negatives is phenomenal now. It really is. And the list of negatives for electric vehicles is, you have to charge it overnight when you're not using it anyway. You know, that's.
Yeah. And with the right infrastructure, that's easy.
Yeah.
That's in the path of being solved already.
Right. And then I'd love to know what your opinion of battery development is, because presumably you're using cells manufactured or pouches manufactured by other companies. You're not actually making the battery pack. You're making the pack yourself, I'm assuming, but not the cells.
Okay. So we're a bit unique about that as well. So we do not do the chemistry. So we don't do this, but we also don't do the pack.
Right.
We use batteries as structural components. Right. Instead of building a Russian doll where you took a cell, put it within a module, and then you take the module and put it into the pack, and then you take the pack and put it into the chassis.
Yeah.
It's a box within a box within a box. Come on, doesn't make any sense. We build them directly into the chassis.
Right.
That allows you for more flexibility in terms of the design, because you don't have to build around the pack that you've designed.
Right.
And you're using them as structural components, increasing the rigidity of the chassis.
Right. So in effect, the pack, if you like, is the vehicle.
Correct.
That's
correct. And if now you look again at our chassis, look how low they are.
Yeah.
They're literally a battery pack.
Yeah. Yeah. And that's got vehicle integrity and strength then. I mean, you've developed it to be that strong, right?
Of course.
And I mean, I can sort of understand that in a small vehicle, but when you're talking like up, because you're going up to 7-ton trucks.
We're doing now, I think, 12 tons already.
Oh my goodness! Wow. So that's because then when if you're driving along a busy road and there's a big truck next to you that is carrying who knows what, you notice the chassis because it's the size of a building. I mean, it's just massive pieces of steel. But you can build something that's as strong as that, but effectively out of batteries. Is it the same idea when you go up to that scale?
Yep.
Wow.
Yeah. That's actually quite an easy part. Now, the larger you go, we believe on trucks, the less does it make sense to use batteries.
Right.
And there you go into fuel cells.
Right. Okay.
If you want to do 1,000 miles truck, that's going to be, I don't know, 25 tons. Just the weight of the batteries that you would need
is huge.
Is ridiculous. You can't carry that. And just to charge it, I mean, God.
Yeah.
And you would say, okay, so why would you use fuel cells everywhere? Right? Because the thing that's called infrastructure.
Yeah.
Nobody would want a hydrogen truck fueling the petrol station, if you'd like, next to your house. I mean, that's not something you want to drive in the city, right?
Yeah.
So you can't use hydrogen currently within cities, but it makes a lot of sense if you want to go long distance.
Right.
Have some outside rural area, some refueling areas. Now, because we reside outside of the chassis, remember, so we are agnostic to the power architecture. So we are using either battery or fuel cell technology.
Right.
And I mean, they both get electrons. Sorry.
Yes, but I mean, can you build physically the same structure, the same skateboard, if you like, but that houses fuel cells and tanks? Presumably, the tanks are going to take up extra space somewhere in that vehicle.
The quick answer to your question is yes.
Right.
Not necessarily you would want to compare one-to-one again, because this is inner city, this is outer city,
sure.
etc. But conceptually, absolutely yes.
Right. Yeah. I mean, because I've always argued that when people go, and I have to say, it's often without much thought. They go, "Oh, hydrogen is better for car." They're talking cars, passenger cars, and I've driven every hydrogen fuel cell car there is, and they're all great. They're great cars, but they're just a little bit expensive, and also there really is no infrastructure to support them at the moment. But I can absolutely see a commercial company that have a truck depot and do long haulage distribution to another truck depot or another depot. That a hydrogen fueling station as part of that depot is perfectly feasible and doable.
Because this is how it's built, right?
Yeah.
So let's say a ship docks, right? And off it goes. You got the Nicolas or Helions of the world, right? The class 7 and 8, right? So they start moving that or the long haul, and then you get to a depot, and from that you got to the class 3, usually class 3 or 4, where the mid-mile deliveries, right? Like the what we do, or the Rivians of the world. So for each big truck, you would need roughly somewhere between 5 to 7 mid-mile trucks,
right,
for the same capacity, right? Okay, good. And then you want to go to the last mile, much smaller one. Again, this is exactly what we do.
Yeah.
And that you would need somewhere between 10 to 13, 14, depends on the category of last mile deliveries to deliver those packages.
Right, I see, yeah.
And this is where you see the chain. Now, you have to hand over those packages.
Yeah.
Where you hand over, you charge.
Yes.
Or fuel.
Yeah. And then, so the other question that I'm obsessed with, and you can tell me I'm mad, is vehicle to grid or vehicle to building, which seems to make, I have a vehicle to grid system at my house, which is we're still working on, but which kind of makes sense. But it's not really a big thing. But I think, if you're a big distribution company, you've got 500 vans, electric vans, the storage capacity, the combined storage capacity of those vans is power station level. I mean, it's huge. And if you can utilize that when you're not using the trucks, when the trucks or vans aren't driving, it just makes a lot of sense. Are you building that kind of capability into the electronics that you're constructing? Is that something you're working on?
This is an interesting point. But there is also another way to look at it. So let's say you are let's say you're an Uber and you drive people all day long, right? That's what you do. But during the middle of the night, there are many less people, right?
Yeah.
So one way is to say, let's utilize the power and put it back in the grid, what you say, right?
Yeah.
But what if you use our platform, which is completely flat? You go to the depot, you change the top hat, and now you're moving goods. Hours.
Oh God.
Frequently.
So the actual drive unit, let's call it that, what you make, is in use 24 hours, theoretically in use 24 hours a day for different reasons.
Like a commercial plane, right?
Yeah.
The crew comes in, comes off. You make a quick swipe there, right? And off there you go.
Yeah.
That's the whole idea. It's built to last.
Yes. Because that is very interesting. I haven't thought of that notion before, but the idea that, because that is the absurdity of the current situation, is particularly with private cars, you spend all this money on your beautiful shiny car and then you don't do anything with it, just leave it there for 90% of the time you own it. It's insane. And I mean, it's not as extreme with commercial vehicles, but there's still a lot of
There's tons of it.
parked away in a car park,
Yeah.
So if you can use that more, that is a very interesting thing. And I mean, that I don't know how technically feasible that is, but I mean, presumably you can build that into the system, that it is literally like a battery swap thing. You just drive it in something, it takes the body off, puts another body on, and it drives out, I guess.
So let's put it this way. Since some of our team has been significantly involved in a program that was called Better Place.
Yes, all right. I'm aware of Better Place, yeah.
One should not be surprised if we are looking into that.
Because I think it was a glorious attempt, wasn't it? Better Place, and I think we can say it wasn't successful, but it was very, very early on, and it made sense to people. Everyone loves that idea.
The problem was mainly technology was not there yet.
Yeah.
Right? So at best, you would have gotten 80 kilometers a day. And
Yeah.
the car was ridiculously huge.
Yeah.
And not that powerful. It was low voltage, not not the case. But conceptually, it was brilliant.
Yeah. Well, there is NIO in China that are doing it successfully. They are, they've done their millionth battery swap now.
And there are many countries or locations where you can't charge. Okay, let's look, for example, at Japan.
Yeah.
Very advanced, right? But where do you charge? You don't have a parking lot. You don't have a parking space. I mean, space is a rare commodity.
Right.
So you usually park the vehicles elsewhere.
Right.
What do you drive all that and then you drive back and you waste all that energy, or what? You take all that money and then put infrastructure? No. What if you come into your depot for load and we just swipe you with a new battery while you're loading your goods?
Right. Yeah. I mean, that is because that's, I suppose the thing is, like, I remember it was a Renault, wasn't it, that was Better Place first used. I can't remember the make of vehicle, the particular vehicle.
It's REE, I think.
Yeah. Yes. But anyway, but what you were doing, it was so compromised, because that was essentially a converted combustion car with a sort of battery jammed in behind the passenger seat. I mean, it wasn't the ideal thing. Whereas if you're from the absolute day one, when you do the first drawing of what you're making, you're going, how do we get the battery in and out of that quickly? It's a lot easier. Yeah. And I mean, then, so the other thing that would facilitate that being more effective, which is what we're seeing happening, is the cost of batteries. Because when Better Place was trying to do that with Renault, those battery packs cost literally a fortune. I mean, they were very, very expensive, and they have. I mean, have you seen that, and are you working that price reduction into your business ideas and structure? Because they clearly are getting cheaper.
So yes, they're not getting as cheap as we would want them to yet. They're still very expensive. Yeah. But I think we see the light at the end of the tunnel.
Right.
In the sense that we see that we're coming into a very dramatic decrease in battery costs.
Right.
Especially if you're not a Tesla, where you need a very high density battery structure, right? Energy density, which not everybody needs.
Yeah.
But batteries are by far the most expensive component in an EV.
So it is still the case in what you're building.
The biggest problem is not actually guys, if building any battery most components, you're doing something wrong,
right? Because
it just means everything else is too expensive.
Yeah.
Right. But the problem with batteries is actually the second life, right? Because if we can figure out what to do with batteries once they're drained under the DOD, the depth of charge that allows it to run on EV, then naturally price will decrease.
Yeah.
But currently, we're not there yet, but think about what happens for all the EVs that are being sold today in 5 years time, 6, 7 years time, when those batteries will be, out of life for them.
Yeah.
What do we do with all that? You can't recycle. So what do you do?
Well, you can recycle, but it's still, it's the last thing you want to do. I mean, we've been to a company that is recycling, developing recycling, but
financially.
Yes, it doesn't make financial sense.
It doesn't make any sense.
No. Yeah. So, I'm guessing that if you would put them in a box and strap them to a building and use them as static storage, because they're still working enough to do that. But I don't know. I mean, what's your idea?
What Elon has been trying to do with I forgot the name, the home battery packs that he used to sell.
Yeah.
It's very easy. You would understand that this would be the second life for the car batteries. You're not going to put new batteries there. It doesn't make any sense. But
no.
I don't think, it reminds me of data. Today you see many software and data companies that taking for granted that you don't work offline, because nobody's offline. Even today on a plane.
Yes.
I can't remember what it means to fly. I think I read about it somewhere. But
I've seen it in movies.
Exactly. But I remember being so thankful for those, minutes where you're in between satellites.
Yeah.
Not work.
Yeah.
And it's the same with that. I mean, we have power almost constantly today.
Yeah.
It's a given. So I don't know if you need power reserves. And if you do need power reserves for short periods of time, and you don't really need high voltage there, using a generator, has been proven quite efficient. Although, God forbid, you're using petrol, but not that much.
But I mean, I think it depends on the grid of the country you're in. So I mean, the cost there's an economic imperative in the UK. The cost difference between the most expensive and the cheapest electricity is massive in this country because of the nature of the way we generate power. Sure. So therefore, like a battery in your house can make economic sense over a long period of time. And it doesn't. I don't think it makes economic sense yet, but I think it could do. I'm an early adopter, so I never use grid electricity like now. Everything that's lighting me at the moment is from the battery. I'm not using anything from the grid because it's too expensive this time of day.
But you touch on something very interesting here. It's not a one-man show in a sense that when you go to electrification, when you go to autonomous, when you want to build a new mobility market and segments, each one has to do, I believe, their own job, and then somebody else carries from there. So, for example, let's think of a good example. Data. All right. So we collect tons of data. Some of it we use, right? We analyze what you mentioned before, preventative maintenance, etc. Yeah. But we also analyze and gather and own tons of other data, anything you can imagine, right? Not necessarily we've got something to do with it.
Yeah.
But if we provide it to the Googles of the world, the Verizons of the world, the V2V, V2X, smart cities, etc., then for them it's pure gold.
Right.
And they can do something with that. And this is why it's so important to create a network where we're collecting those data, and I'm sure somebody else would have something to do with that. You can build a battery pack, but then you need to make sure that somebody knows what to do with it once you're done.
Yeah.
Well, that ecosystem of being able to make it more sustainable.
Yes.
Otherwise, it just pile up garbage.
Yeah. I mean, I think that's the critical thing, is the notion of the circular economy. It's certainly something I've heard a great deal about, talked a great deal about. And the one thing that I was very intrigued with, which was a mining engineer I talked to. So that's his field, is digging stuff up. And he said,
literally,
Yeah, but he actually said, and I've mentioned this on the podcast as well, but he said we've got, and I won't use quite the language he used, but he said we've got to stop digging stuff up by 2050. That after that point, we reuse everything we've already dug up. And one of the key things that he said is mining. The one area where he sees a growth in mining is in landfill. So what stuff we've thrown away in the past over the last 150 years, that's where you have a mine, because you can extract loads of stuff. We've thrown away so much stuff for a long time, but I think that is a really interesting that you've got to create technologies that at the end of their life you can use those materials again. That's got to be a key part of the whole process, I think, isn't it?
Could not agree with you more. Yeah. Absolutely.
Yeah. But anyway, Daniel, look, you've explained it so beautifully, and it's such an exciting idea. And the frustration we have at the moment of not actually being able to come and see what you're doing is palpable. But, we will do one day. I think it's extraordinary. I really want to wish you the best of luck with it all. I think it's fabulous what you're doing. You don't really need my best wishes because you're doing very well anyway. But I just, all power to you for pushing the envelope, and making another step forward in a way with this technology. It's really fascinating. I'm really thrilled to know about it. And we will be posting links to that, because that is an important thing for the listeners to know. The REE website really does. If you're going, what do you mean? Like the wheels are in the corner? Well, you look at that website, it really explains it beautifully clearly. It's a really, really good job. That is very nice. So thanks very much, Daniel.
Thank you all so much. Thank you, and stay safe.
Well, I hope you really enjoyed that episode. I don't know, I must admit, how to pronounce Daniel's second name. Barel, I'm going to go for, or Barel, or Barel. I'm really bad at that sort of thing. But what a lovely fella. Isn't he a great guy? And really good fun to talk to. And they're such an exciting company. Really want to do more stuff with them. But that's all for this week. There's some good episodes coming up. If I was more organised, and I'd written it down, I'd be able to tell you, do a tease, a trail for next week. I can't remember what it is. I know I've already made it. No, I know it's good. One day I'll get that right. We'll organise it. We're getting a bit better with the way we're producing these. We're getting a little bit more on the case, rather than in a mad panic on a Sunday night before they go out on a Monday morning. Anyway, that's all. Please do subscribe to this podcast and tell your friends, and have a look at Fully Charged on YouTube. And as always, if you have been, thank you for listening.